So this is an introduction to the activity, 1.3 activity. So you'll notice that we are activity 1.3. You'll notice it says 1.3 right there. Solving equations on both variables on both sides. So now it's going to be important to think about if there's a variable on both sides of an equation, like x plus 3 equals x. So wow, now you'd have to do something a little different. Of course, this one, if you tried to solve for it by moving the x over to this side, you'll notice that you get a nonsensical thing, x3 equals 0, which is no solution. So watch out for ones like that. But let's say if you had a different one. What if you had x plus 3 equals 2x? Well, suddenly this is one you can solve, so you would move the x over to the other side, and you have 3 equals x. Hey, that's one that has a solution. All right, so that's just an example of how you can have variables on both sides. All right, let's erase that. So the essential question here is, how can you solve an equation that has variables on both sides? So you're going to work with a partner. Each figure has an unusual property that the value of its perimeter in feet is equal to the value of its area in square feet. So value of perimeter in feet is equal to the value of its area in square feet. I should use the highlighter instead. Let's erase that. Value of perimeter in feet is equal to the value of its area in square feet. So notice that equal to there. Write an equation where the value of the perimeter equals the value of the area for each figure. So this is not always true. The perimeter of a figure is not always equal to the area, but in this case it is. Solve each equation for x. Use the value of x to find the perimeter and area of each figure. Check your solution by comparing the value of the perimeter and the value of the area for each figure. Okay, so how do we find the area of this figure, starting with A? So the area is the side length times the other side length. So like that. So we want to say, so area is 3x, and it's going to be equal to the perimeter, which is this plus this. So you could say 3 plus 3, or 2 times 3, either way, plus this plus this. So plus x, oops, I went off the side here, plus x plus x. Or you could say 3x equals 2 times 3 plus 2 times x. Notice that those are equivalent statements. So you can also say 3x is equal to 6 plus 2x. Notice we have variables on both sides, so we need to bring one variable over to the other side and combine the terms. So we need to undo addition by subtraction. So it's minus 2x minus 2x, and you have x is equal to 6, and that is part of the answer. What was the rest of it? They said, find the value of x to find the perimeter and area of each figure. Check your solution by comparing the value of the perimeter and the value of the area of each figure. Okay, so we still need to check our solution. So let's plug x back up into our original area. Remember, this was our perimeter. So 3 times 6 is equal to 18. That's our area. Let's check our perimeter. So 3 plus 3 plus x was our perimeter. Hold on, let me erase that. I'm running out of space here. Oops. So our perimeter was x plus 3 plus 3. Remember, that was our perimeter. Remember, that was 3 and 3 and x and x. So we have 2x plus 6, And remember that our x value, x was equal to 6, and the area was equal to 18. Just remember that from what I erased just now. Okay, so 2 times, let's change this 6 down from here, so 2, it's times 6 plus 6, so we have 12 plus 6 equals 18. Notice that the perimeter is 18 and the area is 18. They said that in each figure has the unusual property that the value of its perimeter is equal to the value of its area. So therefore, we have solved this first one correctly because the area is equal to the perimeter. They are both equal to 18. All right.